So friends, it is 7 p.m. Indian Standard Time, and I thought we should start on time. Thank you so much for making it today. I've been waiting for this wonderful moment. Before we start, I would like to thank Raju for recording this particular talk. It will be put up in YouTube and streamed as well. And heartiest congratulations everyone for wonderful landing of Chandrayaan 3 on the moon. Before we begin, please allow me to take a very subtle introduction about our esteemed speaker, esteemed guest, Professor GPS Raghava. I've known Sir over the last, I would say, 23 years exactly. That was in December 2000 when I was at IMTech Chandigarh as a young master's student. Sir showed us a wonderful instrument in the form of Maldi-TOF, where IMTech acquired at that point of time. Sir was managing the bioinformatics resources. He obtained his PhD in the year 1996 and served as computer scientist across various spheres. And then after having worked for about 30 years in IMTech Chandigarh, he recently moved to IIIT Indraprastha Institute of Information Technology in Delhi. Before moving to IIIT Delhi, he has developed whopping 268 web servers. I repeat, 268 web servers, which probably no one could really dream of or think of. Those are those wonderful accolades GPS Raghava's group has acquired. He has been a fellow of several royal societies, including fellow of National Academy of Sciences, fellow of Indian Academy of Sciences. He has a H index of 87 with more than 27,000 citations, which speaks volumes about his wonderful publication track record. And he has more than 100 publications, reaching a target of more than 100 citations. That shows again how deep Sir has been. But above all, GPS Raghava has been an adherent of open source and open access. His group has promulgated free software for academic use. In that particular process, he has developed a wonderful portal called Computational Resource for Drug Discovery under the aegis of open source drug discovery, which was initiated through Council of Science, Scientific and Industrial Research in India. Furthermore, he has been a JC Bose Fellow. He has received his award, and he has been consistently receiving various accolades in the form of national leadership awards and other things. And most importantly, he has been the utmost cited author from India by Thomson Reuters since 2011. And he was also awarded various other prizes, including the NASI Brilliance Industries Platinum Jubilee Award and various other things. Having come from Meerut, where he was born in Bulandshahr, Sir has traveled worldwide. He has, in fact, such much passion for India and for our country that he wanted to stay in India and ensure that he could do something for India and Indian brethren. That speaks volumes about his this thing. And he has produced innumerable number of PhD fellows, postdocs, and graduate fellows who are there in different parts of the world. And with this little introduction, we'll start this Sciversation today. Sciversation means speaking scientific excellence with conversation. That is how I coined this particular word, Sciversation. We not only discuss science, we'll also discuss conscience. कॉन्शियंस माने हमारे जो मन में जो भी चलता है, जो हमारे साइंस के तरफ से जो भी हम करना चाहते हैं, we'll also try to talk about that. So Sir will start his presentation for the first 10 minutes and then we'll have a quick question and answers. Thank you so much again, sir. So please, please share your screen.
Okay. First of all, thank you very much for inviting me for this talk. And I really appreciate your effort over the years. You are trying your best actually for the service of the bioinformatics. I love it actually. So I will not go into the detail. I will just talk what I feel actually. Because for me, most important part is honesty from yourself actually, rather than talking from the others actually. Because giving the big numbers and all sort of things is fine, but what you feel actually. So I will give you the presentation in a brief. Just I will share. Is my screen is visible? Can anybody confirm whether my screen is visible?
Yes, sir.
Yes,
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 sir.
visible.
Okay, okay. So as usual, if you want more information about me or my services, this is my website. Why I give this website? Because most of my web services, whatever I have developed so far, is available from this website. That's the most important thing. We are maintaining all our software or services over the years. So this presentation is not a detailed presentation. It's a just brief about the my journey toward the science. First, I will talk about the education, employment, and experience. Then I will talk about the research-based services, human resource development, and scientific services. So, as usual, like others, I also did the different degrees. Initially, in primary educations, I did from my native place. It's a UP. Unfortunately, marks in 12th or 10th was not good. And I realized this part when I joined my bachelor's in merit, why I'm not getting the good marks and unable to qualify any competitive exam. So I will not tell any lie actually. I'm not an intelligent person. I am very normal person who fight for the survival actually. So in 12th, I tried my best to qualify an engineering exams. I was unable to crack any exam. So then there is no option. I had to do the BSc MSc. I did my BSc MSc, but here I learned many things actually because I got the hostel. In hostel we have the different environment. Then I got the excellent academic record. Here I was a topper and blah blah blah. Okay, and during this part I qualified the GATE. After qualifying the GATE, I did my MTech degree from IIT Delhi. So till this point, I have no plan that I will do the research in my life. The only plan to get the degrees was just to grab the good job. Okay, so after MTech, I joined the PhD in IIT Delhi. Okay, in the same department. For 6 months, I was there actually in IIT Delhi, and then I got the job at Imtech Chandigarh because I was doing the PhD for the job. Once I got the job, why PhD? So I left my PhD in 1986 and I joined the Impact Chandigarh as a scientist. They hired me to provide the computer services, means to develop the software or need of the small things in the institute. Because the whole institute is Institute of Microbial Technology. So institute is biological institute or microbiology institute. I was odd man out who was providing service to the institute. So what happened? For 5 or 6 years, I love my job because it's a class one officer job, sort of things. Central government job. I was going 9 o'clock and coming at 5:30, 5 days week. So what else you need? 5 and 6 years, I enjoyed up to the 91. Then I realized what I'm doing actually. So I start to do some research. And here the research purpose was not to do any depth research or any new discoveries. Aim was just to extend my services towards the research, because the softwares I was developing at that time, it was only available to the institute. So whenever any biologist put the problem to me, I solve the problem and I write the softwares. So during that time, I came to know about the EMBL, European Molecular Biology Laboratory, okay, Heidelberg. That's basically maintained by the whole Europeans, and the NIH, and they are providing free software, free data, databases are there. So I thought at that time, why we Indians are so selfish actually. We never share our information, where the other part of the world, like Europeans and US, they are even sharing the source code. Because sharing source code means you are sharing everything. That inspired me a lot. So I decided I had to expand my service towards the research, and it should be available to the world. So since 91, I'm trying my best to develop the free software or databases which are available to the community, because I don't want to involve myself in the routine jobs, which is easy to perform. I have to do the jobs which unsolved jobs, let's say unsolved biological problem. So first we try to solve it, and after solving it, we publish it and we develop the software so anybody can use it actually. So during that time, I published number of papers, and then I complete my PhD from the IMTech Chandigarh in '96. After completing this PhD, I went to the postdoc and other part, but job is continued at IMTech Chandigarh from 1986 to 2016. In 2017, I decided to quit that job and to join the new job at IIIT Delhi. There is a reasons. So one of the reason why I joined the IIIT, because the retirement age at IMTech Chandigarh is 60, and at IIIT retirement age is 65. That's the one thing. And second thing, in academic environment, age is not a question actually. So I shifted to this job, and I'm working here since 2017. Okay. Regarding my experience, though my whole life goes in the India, but in between I went to the abroad for short periods. So I was postdoctoral fellow in Oxford University in UK for 96 to 98, where I learned many things under the Professor Jeff Burton, and particularly I learned web technology, because at that time web technology was not there in India at all actually. So I learned how to develop the different websites, database development, all type of technology I learned during this time. During my Oxford program, I also work at EBI. Okay, so I learned many things there. Then in 2004, I went as a visiting professor. I taught one course in South Korea for one semester just to get the exposure and to teach to the students actually. Then I established the Bioinformatics Center at USA first in 2003 and 2006, because at that time in India, whatever we say, our internet speed and other part of the internet was not as good as in the USA and UK. So I established mirror sites of my websites in USA also, so that they get the advantage, they get the services, and I get the advantage. My services have been used widely by the public because they are much faster services. So this is my experience about my education. Regarding my research, as I told you in the beginning, I'm not a serious type of scientist who is doing the serious science in particular area. I came into this area because I have the curiosity. I want to do something. I want to learn something. Okay. But the product-wise, besides the publications, our major aim in our group is to develop the databases. Earlier, we developed the standalone software. Nowadays, we also develop the web services. So sometimes it's a cycle. Earlier, we write the standalone softwares. Web services are not there. After that, we got the web services, and then we stopped the standalone software. Now, recently, we realized that we need to maintain both standalone software as well as web services, because web services cannot be used for multiple jobs, like where you have to download or upload a lot of data actually. That's a problem with the web service. So now we are developing standalone software as well as web services. So it's up to the user which service they want to use. But whole game is how to provide the public domain services. One of the challenge, I'm not talking about India, worldwide, is to maintain these services. Because let's say if I develop any software or any web service in 2002 or 2003, in today's time, it will not work because the Python version, Perl version, or whatever software is there, the library has been changed. So there is a continuous change in the operating systems as well as in the programming language. So how to maintain them is a big challenge for us actually. Because normally we are dependent on the students. So the student did the PhD and then they left the group. But who will maintain their software? So over the years, I'm dedicatedly working on our services, web services or databases, so make sure that none of them go down. So whatever software we have developed over the years, they are available from my website. I have given you the address. So maintaining them is a big challenge in today's time actually. So we are doing that part. So everything is based on this part, beside the publications. Now question is discipline. Discipline is very difficult for me to maintain in one discipline because I feel bored after some time. So for me, it's maintaining in one field for long is difficult. So initially, when I have no idea about the science, I start the general purpose softwares like calculating antibody concentration or antigen concentration from ELISA data. Okay, if you are biologist, you know the ELISA data. Then calculating antibody antigen affinity from the competitive ELISA. Mapping the restriction sites on your sequence so that you can do the protein engineering. Fingerprinting. So these are called the general purpose software. So we develop a lot of softwares. I have just given you some ideas. One of the challenge I found in initial phase is protein structure prediction. So a lot of work in my group goes on the structure annotation of proteins. During that time, I shifted towards the functional annotation of the protein. Mainly, most of our methods, they are towards the subcellular localization of proteins. How to predict the subcellular localization. As well as we work on the genomes, like the gene finder or spectral repeats, sort of things actually. Third, which is one of my favorite field, despite I shift my field time to time actually, I'm not the person who is consistent with the field. Is still one field which I'm coming time to time and working from long time is computer-aided vaccines. I started this field in 2000 and we developed the B cell epitope, T cell epitope, or whatever is required for developing the vaccines we are working. So for some time, I stopped this field and later on realized new development has been taking place. So I had to cope with the new softwares with the new development. And then I'm coming time to time in this area. So we have too many databases, softwares in the area of computed vaccines actually. We simply call subunit vaccines. Another area which I changed in the 2008 when there was a program mentioned that CRDD, Computation Resources for Drug Discovery, was part of the OSDD, Open Source for Drug Discovery. During that time, I started the new area where it's called drug discovery, where Already I was working on the drug targets earlier also, because functional annotation of proteins or structure annotation of proteins directly help you to identify the drug targets. But I started the other area, like designing the inhibitors, docking, identify the right type of drug molecules, small molecules. But I realized too many people are there. So I had to have some different areas. So I jumped towards a peptide-based therapeutics or protein-based therapeutics. So over the years, we have done a lot of contribution in the field of peptide or protein-based therapeutics. Rather than using the small molecule, we are using peptide or protein as a drug molecule. And this field become very popular actually. A lot of people are using this area. Another part is genetic biomarkers. Genetic biomarkers means, let's say you want to do the diagnostics, or in the cancer you want to do the prognostic biomarkers, or risk, for risk prediction of the cancer patients. So based on the gene expression, maybe mutations, or maybe epigenetics information, depending on your need actually. So we are working in this area. So if you see carefully, from the application point of view, computer-aided vaccine, computer-aided design, and genetic biomarkers. These are four. There is a one area which is called need-based area, because sometimes, let's say recently we have the coronavirus. So most of the researchers say you have all the tools. Why don't you provide a platform where you have the predicted, please mind, predicted vaccine candidate, prediction drug candidate, prediction biomarkers. Okay, why can't you do it? So we provide the different solutions for a particular virus. Here examples, or for cancer, many platforms we have developed it. So the aim is basically we are providing the predicted information. So instead you do searching, you do the prediction, we are providing to you. As I told you in the beginning also, so that one of my objective is to serve the society. For me, serving the society is more important than doing the science. So I'm using my science skill or my scientific contribution to help the public actually. I started my group in 2000. So in nearly this 23 years, more than 40 students completed their PhD. Presently 10 are working. And I have helped many people actually, as well as I am teaching my courses here on the different courses, and they are very popular. So at least I am teaching 300 students per year actually. So that is basically towards the human resource development. And I am providing long-term training where number of students work on the PARA, other positions, as well as short-term trainings. Over the years, we have organized number of conferences, workshop, and training program. Because I am also part of the BTIS net of the DBT, where one of the mandate is to provide the service to the community. And that's why a lot of people knows me in the area, because they have attended the conferences or workshop organized by my group actually. So that's another type of service we are providing to the community. Of course, I deliver the lectures in the different conference workshop. I consider it's a service to the society. One thing I would like to mention here, because when you talk about the science, that's a tragedy actually. A scientist claim that I am providing service to the community. Same time, there is a miserable life of his or her PhD students or the students working under the scientist. So sometimes I feel the scientists are not thinking. They are thinking that they are giving the service, but meantime, they are basically sucking the blood of the young generation. I don't want that type of service. So I make sure, since I start my group, that I will try my best to have the best relationship with my students, with my subordinate, so that they also feel that they are part of the system. I am not the person who extract maximum from the students and others actually. Aim is to provide the service to them actually. So if any PhD student work with me, I have the simple statement. I am here to help you, not to extract from you. So we work as a team. In last 40 years, in last number of years, we have too many students, but there is no single fights. We are enjoyed. We work together. We work as a team. So that's my message to my young generation as well as the guides actually. Please, if you want to serve the society, but not the cost of the others. Actually, you have to remember this part in your life. Actually, if you are taking the blood of somebody and then you are serving the society, I don't believe in that theory. Anyway, so that's a human resource development. Another part is scientific services, because initially we developed the standalone software and distribute it through the floppy, CD, or email. But in 99 onward, we are writing the online services. So we have developed our major attempt over the years is whatever the knowledge we have achieved or whatever we have obtained, how to distribute to the public. Because nobody is permanent in this world, we have to die. So we have to document whatever the knowledge we have obtained, as well as we should to know how to distribute it. So even if you are there or not there, others can use it. So we have made the number of attempts. We developed the CRDD portal where the lot of links are provided related to drug discovery. We developed the OSD Linux, which is basically platform, virtual platform, VMS system, where you are basically using the. You can see my slides.
Yes, sir. Yes, sir. Yeah.
So GPS or Docker, these are the some services. So that's all regarding the presentation. Okay, and I will remove my presentation. All right. Now, yeah, I'm free.
Yeah. Thank you, sir. Thank you so much, for the wonderful presentation. It's indeed a great honor in having you having learned about your life and all those kind of things. That's wonderful. So what we'll do is, sir, for the first 20 minutes or so, I'll ask some questions, and then we'll have some Q&A session from the audience as well, so that they wanted to interact with you. Sir, over the years, many labs have really developed databases and web servers. One of the major challenges for development of these web servers is reinstantiation of the code. And not only that, if we really talk about any databases or web servers, reproducibility is one important concern. Sometimes utility is a concern, sometimes security is a concern. And most importantly, maintaining these humongous databases and web servers is another concern. How could you do this, sir? How could you master this over the last 30 years? How could you ensure that each of these 260 and odd databases or web servers that you have developed, they're alive? What is that mantra that you have?
That's a dedication actually. I will tell you why dedication. Let's say because recently I will give you the example, you will understand. Last few months, not now, few months, lot of hacker attack on my systems, and they capture it actually. Sometimes they capture some parts actually, okay, because in the Ubuntu 22 there is some security bugs was there, so they enter in my system and create lot of problem. At that time, 1 or 2 months, I have not bothered about my research publications that PhD students are involved, they will work and also, but I day and night, I work, find out the solutions and then work it. So the work you can see outside, whatever the visible is there, is a small part of my work actually. But inside, I spend daily lot of time on maintaining operating system, maintaining logs, make sure that every system is working. It's not easy because when you are getting the hits of tune of 2 lakhs it's per day actually. Sometimes the hits are from the hackers also actually. They try to hack it. Recently, there was a news actually. Somebody claimed that our system have been hacked, our information have been leaked. There was such type of news is there. Then I write to them, I think you are wrong because we are not maintaining any secret information. Every information is open. So even if you take the information, who cares? You got my point?
Yeah.
Because that's a strategy by the hackers that first they will claim that they have hacked our system and then they will ask the money. Okay. So I say I will not give you any money because the system is not hacked. Every information is only freely available actually. So what you will do with it? Okay. So you are right that work is not visible to the community. I work day and night for this purpose to maintain, because if you are really dedicated to provide the service, you have to spend the time. Second thing, problem in Indian system is, I will tell you the Indian situation. Most of our research is based on our students, either PhD student or maybe short-term training or whatever is there. They are interested in their research. After, let's say, for PhD student, after 4 years, 5 years, they will go. They are not bothered whether it's maintained or not maintained. It's your duty. So you have to be dedicated. If you are only worried about your career, that how many publications you want the in a year 10 paper or 20 paper, whatever. Okay, then you cannot maintain your old services because you will feel what I will get. Because even if I maintain the old servers, I'm not getting any extra paper. I'm not getting extra thing. Only thing that's a dedication because I feel that that is part of my dedication that to provide the service to the community actually. Because I love it. One thing is love it. Because when you do the service to the community and you love it, then you can maintain it. When you do the service to the community, just to you want to get something from the society back. Actually, if you have that type of feeling that you are serving the society, of course that's fine. But I need something actually from that. Actually, then that's a problem. You cannot maintain for long because everything you will calculate. That's one of the reason in Indian system people are too smart. They only work when they get something from that. And if you are dedicated service provider, you will not bother whether people like it, not like it, what they are thinking, but you will do the best from your side. So that's the only reason I'm able to maintain it. I'm not bothering or calculating any mathematics.
Wonderful, sir. Very, very well said, sir. That's quite very inspiring. So moving further, if you really talk about the science, the wonderful science in the form of databases or web servers that you develop, you are also a very fast acclimatizer. So, for example, when SARS-CoV-2 came in 2000, I mean 2020, it so happened in 2019 December, you could develop a wonderful resource within just few months. I mean, having had that kind of an expertise in development of databases and web servers, at the same time, you should also have wonderful knowledge behind that particular viral biology and all those kind of things in order to develop a rigorous web resource. How do you train your students, sir? What is that kind of philosophy that goes through in your lab? How do you ensure that this is successful? Yeah.
So I will tell you one thing actually. This is my experience. Frankly speaking, whatever I'm talking, it's not universal truth. It's basically whatever I feel actually. What I feel, our teachers sometimes is not honest with the students. They want to create hype in their mind that they cannot do it. They put the negative energy. I put always the positive energy. Because most of my PhD students have no prior knowledge of computers. They are all biologists. You can check the biodata of my PhD students. They join me. Okay, they simply say, sir, we don't know what is a computer and all. I said, that's not required actually. Because computer, you are scared from the programming. Programming is nothing, it's a basically set of instructions. So here, if you know how to communicate yourself, you can communicate with the computer. Only thing it's a slightly different language. Rather than using the English or Hindi or Telugu, you are using a small set of language that's a much, much smaller than any natural language actually. So I always keep teach them in such a way that they feel confident they can do it. All these web services, frankly speaking, they have been done by the students. And another thing, you have to respect your student. That's the one thing that people should learn actually. That's the one problem I have seen in Indian system actually over the years actually. They, as you grow, as you become senior, your ego becomes so high. You do not respect the others actually. People need the respect. Whatever the age is there, it doesn't matter at all actually. If you respect with them, you discuss with them, they will do more work actually. In fact, people will surprise. In my case, even my manuscripts are written by my PhD students. Only I look on them when just in the final stage, and then I give the suggestions only. Because I told them a number of times, ultimately, you have to be the independent researcher later on. If I will write your manuscripts now, then later on you will not become independent. So I want to make them the independent researcher rather than. So this is a two-way traffic. I save a lot of my time as well as I utilize their expertise, and they also feel happy that they are contributing. When any biologist develop the web server or database, they feel happy that it's their work actually. And I feel happy that I am able to transfer the knowledge because it's not important how much I learn. It's important how much knowledge I will be able to transfer to my PhD students. And computer science is not a rocket science actually. That's unfortunate that people put in the mind that it's a rocket science. Nothing is there actually. That's nowadays, if you want to implement machine learning, deep learning, all these things, there are libraries are there. You can implement it. Just teach the student in a simple way rather than in the complex way. Because sometimes we want to teach in the complex way because we want to show to them we are the great. We can also explain in simple ways. But if you explain the simple ways, you feel that people will not be impressed with you. So then you go to the complex way. So I have the simple theory. I don't want to show anybody that I am the great man. I want to show the purpose is how to transfer the knowledge. And they work very well actually. And I told you in the beginning that between me and my students, there is a good coordination. So there is no tension to the student as well as to me. So I think that's one of the reasons actually.
Wonderful, sir. I mean, that shows how great mentor you are. That's quite amazing. Sir, certainly moving towards the databases also. If you really talk about some databases or web servers, or for that matter, any bioinformatics applications, sometimes we get carried away by the metadata. Sometimes we think that this metadata देखने से ये हो जाएगा. Can we say that this metadata could really allow us to say that this is a good database or this is a good web server? Can we come to that kind of an assumption given the current prolific development of various databases or web servers that people are making? Yeah. How important is metadata in bioinformatics?
Okay, if you carefully look in our databases, most of our databases are really predictive databases rather than any predictive database or derived databases. The reason is there basically. Till today, whatever we say except few fields, bioinformatics is not as mature that you use the predictive information to create the further databases. So the error will be propagated. So the quality of the data will be the problem. You see that in most of the cases when we create the databases, we only store, save experimentally validated data because that's the most important part is experimentally validated data because you need some verification that information is correct. So we normally prefer the curated data, experimentally validated, rather than driving data from data actually.
I agree, sir. That's wonderful, sir. Sir, moving further, there are almost 268 web servers you have developed. Is there any? I know all of them are your favorite databases and web servers. Is there any database or web server that is very close to your heart, where you have taken a lot of challenges in developing that particular database or web server? Is there any specific thing that is very close to your heart that you wanted to discuss today?
Okay, I think I'm not attached actually. That's maybe my weakness or maybe my strength actually. I never attach myself with the work. When I work on any problem, it's near to my heart. Once it is published, developed, then it's a part of the duty. So, but it happened the other way around. Number of times I'm unable to guess what the public wants. Sometimes I work hard, develop some database or some software, and I feel that a lot of people will use it. Hardly anybody use it. And other way around, where I have developed it within few days or say weeks, and it is heavily used actually. Like for example, I can give you the example. There is a person called Prash, which is one of the old servers. So what happened? At that time, there was no software for MSC binders. There was a T-epitope, which is commercially available. So I asked my student Harpreet Singh that ask the developer to give the software. They give the condition either make us a collaborator or give the money. So I was just not happy. So I told Harpreet Singh, he is a scientist in ICMR, I told him that look, you can do same thing because it's based on some paper in the Nature biotechnology. He take it within 1 month, he develop it. So it's not a big job. It's just hardly 1 month job prediction. This become a base for the MSc prediction, and it's more than 1,000 citations we got it actually, and heavily used by the community. So it's not a big job. It's a only small job. So sometimes it works. Another example, very interesting example. I was excited with my students that we will work on the predicting the toxicity of peptides. In 2013, we developed it with my students. And for few years, up to 2019, 13 to 19, it was hardly cited 150 times. Okay? We feel it's okay. 150 is okay. 6 years. Then, coronavirus come, COVID-19. After that, it is heavily used. Nowadays, it is cited more than 300 times per year, actually. Getting a 300 citation per year is a big thing. Now it's a more than 1,000 citations. So in 2-3 years, it's sometimes what happens, you do something, and at that time it is not required or you are too advanced. Okay, but people later on realize, yeah, it's important. So they use it. So one of the important part in bioinformatics, we have to understand what is the need of the user rather than what I want. Actually. Because there are two type theories. One, you work for yourself. One, you understand what is the need of my user. And based on your need, you try to develop it. I am in the second category. I'm not bothered about my research. I'm bothered what my user is. That's why I go everywhere for giving the lecture, even go to the college and all sort of things. Most of the people, big guy, they never go for the small college and I go everywhere. Because when I talk to the students, they give me the real input. What is required actually, rather than I think myself actually.
Right, sir. Wonderful. Sir, wonderful explanation. So moving further, sir, I mean, your forte has also been into machine learning. I mean, given the future of web servers or web development that we are talking, is there any need of integrated machine learning heuristics or integrated machine learning tools that we are going to embed in these web servers? That is number one. And number two, is there a kind of an automation that is needed, especially for bioinformatics scenario, and that too in the adage of this Chat GPT and Google Bard? I mean, where do you see this kind of scenario going in the next 10 years, sir?
Okay. According to me, let's say, as far as the machine learning is concerned, so most of our prediction methods, they use the machine learning. So we are using the machine learning because nowadays people are talking nowadays. Even if you see our servers, we are using machine learning from last 25 years actually. So machine learning for us, it's just a one tool actually. It's nothing. Machine learning or deep learning, not a big deal about it. Regarding the another part, this integration or pipelines or automatic part, I still feel in bioinformatics, we have not reached up to the level where our tools are perfect side. So let's say if you make the pipeline, you take one genome to protein annotation to blah, 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 go down, then error will be propagate actually. I still feel it is not
Yeah.
possible till your tools are quite perfect. Let's say, for example, restriction engine mapping. There is no problem because the tool is perfect. In restriction engine, you can easily find out where it will cut, where it will not cut. Okay, but even if you predict B cell epitope, still B cell prediction is not perfect. Whatever the claim, let's say I also publish a lot of paper, others also publish a lot of paper, but reality is there actually. If you check on a data set which is completely unknown to anybody, the method, the performance of every method will poor. So when there is an error in the tools, so even if you integrate more and more tools, then error at this place, then error will propagate, then next. So I think still it will take some time actually. This is my opinion actually.
Right. Wonderful, sir. Wonderful. So moving further, sir, I know, with such a wonderful academic honesty that you have been keeping over the years, I'm sure you might have disagreed in an agreeable way with many of your colleagues over your 4 decades of experience that you have had. So, are there any instances where you can tell our younger audience how you might have disagreed in an agreeable way on any one instance? Because आजकल के यंगर जनरेशन में, ड्यू रिस्पेक्ट एवरीवन इंक्लूडिंग मी, हम किसी बड़े या किसी प्रोफेसरेट लेवल साइंटिस्ट के साथ हम बात करने लगते हैं, हम प्रोबेबली एग्री टू डिसएग्री नहीं कर पाते हैं. Probably either we probably bring up those heated arguments, and we probably our morale थोड़ा कम हो जाता है, and we cannot probably move forward. So this is a kind of a general question that I've been asking all my guests. एक कोई भी इंस्टेंस अगर आप बताएंगे, for younger generation, so that they can learn some things from you. Yeah, thank you, sir.
Okay, I will put my experience here. So what I feel actually, when I was young, I was starting my career. Even my students, my faculty are more frank with me. They disagree. They say, "Sir, no, this is not right. This is wrong." But with the time, I don't know what is the problem in Indian system. When you become little bit senior or bigger, they are not arguing against you. And science cannot grow till you have the argument. Nobody is perfect in this world. We are all learning at all stages. So most of the time, I have the learning because I have the good communication with most of the people. Because you people know about my publications and other things. You don't know my communications around me. Let's say I daily go to the tea with the tea clubs. I enjoy my friends. I talk to them. I talk to my friends frankly without any restrictions. And during that idea, a lot of ideas generated. So I accept this part actually because I got a lot of ideas, because I have a lot of communication with all the age of the people. Despite any age or any bar, I talk to the people, even senior, junior, and during these discussions, we generate the ideas. So sometimes this is a misunderstanding that only senior person or the person who have the experience have the idea. No, that's not the right. Everyone have the idea, and particularly young generation have a lot of ideas. Only thing, either they have been suppressed by seniors, or these young guys are unable to express themselves actually, because due to the environment. Because in our environment, we don't like anybody argue against you. In fact, I want to say a very interesting part. I was never be a favorite employee in the institute in the starting phase particularly. My CRs, if you see annual reports, they are all bad actually. And one of the reason I got that first report, which is very bad actually, I asked my boss, why you give me the bad report? I am the person who always do the job. He said, you don't know how to behave like a scientist. You have been hired here as a scientist, and you are talking with the junior colleagues and the staff in this institute. You are taking the tea with them. You are eating the food with them. I say, first, before becoming a scientist, you are human. All are human. So you should become first the human. Then you think about becoming any scientist. That's a problem. We become the professor rather than becoming a human. So maintaining yourself as a human is most important for me at least. So what happened? Very interesting phenomenon. What happened when I become senior over the time? then my life become more easy because my junior accept this theory, human to human communication. Okay, but my senior doesn't accept it. I never get the merit promotion in my time actually in my institute because they feel he is too argumentative. Because if I feel whatever the post you are, if I feel it's wrong, I will say wrong. Whether you like it or not like it, I will say polite, but I will. Sometimes the senior people doesn't digest it. That's the Indian system actually, unfortunate. But that's a you have put the good question actually. We have to think about it.
Wonderful, sir. I completely agree on this. Yeah, very awesome statement. So moving further, I mean, if you really talk about bioinformatics in India, there are about 73% of bioinformaticists who claim themselves as chemoinformaticists. In fact, they're either chemists who have been into docking or who develop certain molecular simulation methods or structural docking methods, or they are adept in so-called computer-aided drug designing and all those kind of things. As someone who has honed certain wonderful interest in computer-aided drug designing, because ये आपका forte है, this is something very close to your heart. We in India have not yet been able to develop a kind of a single drug molecule, taking the realm of computer-aided drug designing onto the bedside. Matlab, taking the in silico based approaches or taking from the bench to the bedside. I know it takes some time, but are we something very closer in realizing this particular dream, sir? Do you have any quick comments on this? Yeah.
Frankly speaking, I am not in this area, but I have the experience. Let's say I will share one experience. If you in Indian system, if you are basically individual researcher, Indians are the best. Let's say whether you are playing satranj, okay, chess players or whatever the games are there, you see we are the best. When the questions come in working in the group actually, then there is a problem. And this effort of bringing any molecule into the market, you need the teamwork, money, and the dedication of the people. Let's say I was just very simple example I was discussing with my wife actually. In ISRO, they have sent the Chandrayaan. We all know it. But if you see carefully, how many scientists of the ISRO are known to the public? Very few. Because if their mission is successful, then only director or project director they are highlighted. Most of them they are not highlighted. So that type of dedication is missing in most of the places. Let's say in the CSR or any other issue I have seen over there. We work for our own career, we work for our own work. So if everybody work for the own, you cannot bring the big thing. I can develop the softwares and also that's a small group activity. But when you talk about the drug taking to the market, you need the big team, money and everything. That's where the whole problem. We got in India, we got number of, I'm not saying about the grants, we got the big grants. Ultimately, the people take the grant and they do the same thing, whatever they want to do it. They want to make their careers, but they are not interested to make something to the public. This is my feeling actually. I'm not saying right or wrong.
Wonderful, sir. I think that was a very candid statement, a very lucid statement. Thank you so much, sir, for this. So without wasting much time, I think there are some questions which I'll probably read it and I'll probably ask the presenters or the attendees, to ask some questions. Jai Kishan Solanki works for Unipath Lab, sir, in Ahmedabad. He is a young student. He works on NGS and other things. Jai Kishan asked that, sir, I have one question. Your group works on diverse areas, but still in community people are not ready to accept the development of in-house tools. So my question is, when will India replace wonderful gene banks like MBEL, NCBI? When do you think that we in India could develop such kind of these things, and when do you think that we could replace them? Yeah.
Okay, that's interesting because I will tell you that today morning were discussing with somebody in the US. Developing database or maintaining database is not a challenge. Question is generating exponentially validated information. If you see carefully, most of the data they have come from the US or Europe. You see, India is trying their best from the DBT, DST, ICMR. I am as a part of the committee of the number of organizations. When they are giving the grant, they are forcing the PI, please share the data, share the information, so we can create the database or we can create the information related to the Indian data, because Indian data is missing. So हिंदी में बोलते हैं ना, जब तक घोड़े का मन नहीं होगा पानी पिलाने का, पानी तक ले जा सकते हो, पानी नहीं पिला सकते आप.
सही.
तो होता क्या है? So what actually is happening? They are putting the conditions. So the PI take the money, promise everything. When you ask them data, they will say we are under the process, we are still cleaning, and meantime the project will finish. After that, PI will not respond at all. So the problem is, जब तक जो माइंड सेट्स हैं वो चेंज नहीं होंगे, तुम जबरदस्ती रिसर्च नहीं करा सकते. The problem is that we are not sharing the data. Either we don't have the data or we don't maintain the quality of the data. That's why we are scared to share with the public. I will tell you the challenge. Like I share everything with you, but that's dangerous. If some mistake is there in my code, it will be exploited by the people actually. You got my point? So I should have the confidence enough that whatever the work I am doing with the full honesty. Sometimes the people are doing the work where it's not producible. This is a problem, let's say, worldwide actually. In cancer research, 50% research is not reproducible actually. And if you see the India, it's I think more. So I agree it should be there. I fully agree with it. But unfortunately, I don't know when it will come.
Right. Wonderful, sir. I hope that answers your question, Jai Kishan. Sandeep Seni asks a question. Wonderful resources were built by your lab. Any plan for making resources for omic data analysis? That is the question by Sandeep Sani. But Sandeep, omic, multi-omic data analysis के लिए कोई web servers आप बनाना चाहते हो क्या करके Sandeep Sani का question है sir. But I think Sandeep, before Raghava sir answers, sir has developed those computational resources for identification of I think cancer biomarkers. There are a couple of web servers that their group has developed. Yeah, please sir, please.
Yeah, a lot of servers are there because I never divide it in the problem omics and all the business. So whenever I always work in the problem oriented, let's say cancer biomarkers or other gene prediction or respector repeat finder. So we have a number of tools out there.
True, sir. Yeah. Thank you, sir. Yes, Saraj, please unmute your microphone. Yeah, and please quickly introduce yourselves and please be very brief and specific. We don't have time.
Good evening, sir. I am Saraj. I have a startup in the field of biotechnology and diagnostics. I am working to generate some recombinant proteins and then explore its use in the clinical diagnostics area. I've seen your research and spoken to a couple of your students, I think Diljit and some others. They're pretty helpful and knowledgeable. My question is, I see bioinformatics tools have become commercialized from the US and Europe. For example, SnapGene used to be free 10 years back. Now it has turned to a subscription model. So do we have a scenario where, Indian industry comes up with similar products focused on bioinformatics? We are slowly doing the instruments, but how far are we from, developing these kind of products for bioinformatics?
I think I am the wrong person because I am the person who killed the number of companies actually. Yes, that's a fact of the life. Because T-Epitope is the first example where the company was there to sell the software for predicting the MSC binders. We developed the software which is freely available and the company was closed after some time. So we are the person who are killing the software. So I don't know about the commercial market, but one thing, let's say from user perspective, from your point of view, if you are really interested to use the softwares, freewares are as good as the commercials. So that's fine. But if you are interested in the commercials, I'm not the right person actually. because I never ever promote the commercial business. Even my package number of time I get the offer commercialize them actually. I refuse it that I will not go for the commercialized because my aim is there. Few people should be there who are dedicated for the open source. Because I will tell you the problem. Country like India, getting the money is a big problem. So we need the open software so we can also do the research actually. Like for example, docking. You don't need to spend the money on the docking. There are a number of softwares are there. We demonstrate it. They are as good as any commercial software. So without spending the money, you can do the research. So I am the person who favor the public domain, so I cannot.
Right. Right. Thank you, sir. Saraj, I hope that answers your question. Thank you so much for asking. Sir, Harpreet, yeah, please unmute your microphone. Yeah. Paji? Harpreet? Harpreet? Yeah. Sir, I'll ask Harpreet's question. So
Yes, Prash, I will request you to ask the question.
Oh, okay. Yeah. Yeah. Harpreet asked a question about how do you think about the importance of inclusion of bioinformatics at different levels of education and curriculum from school to graduation level? That's because people from traditional systems are still resistant to recognize its importance. And what should be a positive approach towards this particular direction?
Okay. Let's say this is an interesting question because over the years, sometimes we are encouraging our students to go to the bioinformatics. Other side, students are not getting the job as expected. The problem is there in the education system, people are also behind the money. The number of private institutes, even they don't have the expert, they start the courses. Okay. Where they have the half-hearted expertise. The problem is they blame that they are not getting job, but same time they have the problem of expertise. I will give you the one example. We have started one course here. We call that BTech course that is called CSB, Computer Science and Biological Sciences. So what we did actually, for 2 years, we taught hard computer science with only few bioinformatics or biological courses. Okay, they come through the JE exam, so they are as good in mathematics and other fields as any other students. And then we are teaching third year, fourth year the interface of the two, computer science and other. So even any job anywhere in the computer science, they can easily get. So I mean to say, if you want to make the career, you should not only think how to implement the software because anybody can do it. Then you will not be able to prove yourself that you are better than others. So I will suggest in Indian system you should also go towards the development side a little bit, so that you let's say if today I leave this job, I have no problem. I can get any job anywhere in the computer section because I am too good in the computers. Same is true with my students actually. They never face any problem. So far, I have trained too many PhD students. They never ever face any job problem. So the problem is changing. We have to change a little bit towards the development side as well, rather than simply using side. Because using is not a big deal. Anybody who knows the English can learn it because they are user friendly. So that's my suggestion. We have to go towards a more computation.
Right, wonderful, sir. Yes, so please unmute your microphone and quickly introduce yourself and ask the question, please. Please switch on your camera as well. Yeah.
Uh, so actually, I am not in the right place to for camera. Sorry.
Yeah,
Okay.
sure.
Sorry. Sir. Okay. So sir, myself Somnath. I am doing my PhD in Busan National University, South Korea. Um, so my one question is like we have lots of tools, and you have also generated lots of tools for the protein-based drug discovery. So currently, actually, my lab is working on RNA-based drug discovery. So I we are facing one issue like for when we are actually predicting the binding sites of a particular RNA, there are very lacks of tool because actually we are using some GitHub codes and everything, but we are not sure that is it correct or not. So from your lab, can we get any tools which can bind the RNA binding like pockets?
Let's say in our group, we publish the papers, and tools are there for predicting the RNA interacting residue in proteins.
Yes.
That protein is there, so where the RNA interacting will be there. First we developed in 2008, but it become old. So last year we published the paper in the briefing in Bioinformatics that predict that name is pprint2. That will predict the RNA interacting residue in a protein.
Yes, sir. But the thing is, in the I use a print 2.0, but there actually we need to put the protein sequence. But so my question is, we have some RNA sequence or RNA structure, and as you know that for the RNA structure, the most difficulty to getting the stable structure. So suppose we are getting a very small stable structure, means for predicting the pockets, a very small stable structure is a big deal, because sometimes we saw that if we have like 10 or 15 base pair sequence, and if we are going for the finding the pockets, we can see that there are no pocket, only one pocket saying, and the drugability score is 0. Then so in this case, how we can overcome with that, and we can go for the CAD like next?
Frankly speaking, I have no idea this problem. So it's a research problem for you. You can develop a tool.
Sure. Okay, sir. Okay, thank you so much.
Yeah. So I hope yeah, that is good. So one final question before we move. This is from Pankaj Kurana. She is a senior scientist at ICMR. She asks, I think this is rightly answered by you earlier. She asks that manually curated databases require regular updates. What can be done to maintain them in long term, so that they can remain relevant and impactful?
I fully agree that's a challenge actually for many people, because after some time, information becomes redundant, means it's not updated. So in that case, because that's a big challenge actually. So, in my case, the PhD student will go, who will update it. So what we are doing, we have find out the alternate page. So after a few years, we are developing the new version, second version. So the new student will be interested to develop the update. So nowadays, if you see from our group, like pprint2 is a good example of the software, and there is a number of databases actually, like HMR-based2, that is for hormone-based receptors, developed 10 years back. Now we have developed with the new version, which is latest information. So this is the only way you have to do in India, because in US or other places you have the manpower where they will update it continuously. But in Indian system, it's a really difficult. You have to find out jugaad how to do it actually.
Right. One final question from Anuj. Anuj, please quickly ask in about 15 seconds, please, and if you could. Yeah.
Yeah, am I audible?
Yeah, please.
Yeah, thanks for that inspirational talk. Actually, I just want to know that because as a young students for the biology research, we are very much getting some distraction and depressions while our experiments are not going in our way. So may I just know from the Dr. Raghava that how we can stay motivated and to do some good science as you are having that patience to go with that machine learning and AI even so.
It's a difficult question. So just one thing you have to learn actually, how to overcome your inhibitions. Actually. We all have the capabilities, because one statement is there from my teacher actually. They say when I was doing MSc that now you are master. So I say, yeah, how can we become the master? He said, doesn't mean you know everything. It means that you have the capability that if you want, you can master any topic. I mean to say, though you are a biologist, you should not have fear in your mind that you cannot master the computer science or you cannot master the machine learning, deep learning. So inhibition in your mind should be removed. Actually, that's the most important thing, because we have a complexity that we cannot do it. Because from childhood it has been told to us that you are not good in math, you are not good in, but here you are mature. If you have already MSc, because you are already MSc doing a PhD, okay, you have the capability that you can do it. Only thing you have to remove your inhibitions. This is my
wonderful, sir.
Yeah. Thanks a lot, and a huge clap for sir.
Yeah,
A
yeah.
huge clap.
Thank you so much. So before we have this big round of applause to Sir, I would like to thank Dr. GPS Raghava, who is not only an inspiration to many, not only towards development of web servers and databases. He has been, single-handedly doing human service, for many bioinformaticists, for many budding bioinformaticists. Even at this particular age of 67 also, he tries to spend, quality time towards his students and all those kind of things. And more than that, we were quite honored that, Sir served as the first president of Bioclues Society. Can someone please mute your microphone? We are getting some background noise. Subbu or someone. Yeah. He served as president of Bioclues Society, the first president of Bioclues Society, and that was when Jayaraman sir was the advisor in chief. And then subsequently Jayaraman sir took over, and that was, I would say, golden period where we could bring a lot of members, and they could organize wonderful events. And we also announced Bioclues Innovation Research and Development Award things. One of the other things about Raghava sir is that you just drop him a kind of an email. I mean, any small Tom, Dick, and Harry, he would definitely reply back. That shows the kind of down to earthness that he does. And even if you probably give him a kind of a WhatsApp message or anything, he always has that kind of wonderful this thing. So friends, I hope you all will agree that today's Sciversation is indeed a kind of an impeccable Sciversation that we have ever had. I've been longing for this. In fact, if it were bioinformatics, we always go synonymous with GPS Raghava, not only in India, but also down south. So let's all switch on our camera. Let's also unmute our microphone. Let's stand up, all of us, and give him a standing ovation for the yeoman service that sir has been doing over the years.
Thank you, everyone. Thank you, everyone.
So thank you, sir. We'll just take 1 minute. लोग बोलते हैं कि मैं बहुत अच्छा फोटोग्राफर हूँ, उसको तारीफ नहीं करना चाहिए. तो सबको एक बार. Yes. I know. सुब्बू भी बहुत अच्छा फोटोग्राफर है. राजू भी compete करती रहती है आजकल मेरे से, फोटोग्राफ के लिए. गोल्डी भी आजकल she has been competing. So please, all of you, please switch on your camera. One final moment. Sushil, Anuj, Neetu, Dinata, Neha, Niyas, Pankaj, please. Thank you for joining. Yes. Prabhanjan, you'll be missing this. Yes. 3, 2, and 1. Yes. Thank you so much. Thank you so much, Raghava sir, for your wonderful time.
Thank you, everybody.
Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, Dr. Raghava, and